All right, and last but not least, this final lesson just has us look at Boolean statements as well as conditionals in a little bit more advanced way. So you're going to see how there are some extensions, there are some ways to extend your Boolean statements, there are some ways to actually put if statements within if statements, and I just want to show you what that looks like. So if you decide to use this concept in a program that you're creating, you have the ability to do that. So your goal by the end of today's lesson is to be able to use complex Boolean statements in Python. And I know that you can already do that to some extent, but now we're going to have ones that have maybe more than 2 simple Boolean statements in there. And then you're also going to be able to explain what a nested conditional is and to trace through some code that contains a nested conditional and hopefully even be able to incorporate it into your own future programs. So what we're going to briefly look at today is what on earth happens when we have multiple ands. So this and this and this and this. You could have more than 3, but what happens when there's more than 2? So think through in your head what you think might happen. Just think about it for a second. And then on the next slide, we're actually going to talk about what we would do if this was in our program. So hopefully you had some gut instinct when you saw that code on the previous page. And my hope is that after learning how the and worked, you already kind of knew what was going to happen. So multiple ands works just like 2 ands. In order for this statement to evaluate to be true, all 3 of these statements need to be true. So regardless of how many ands that you have, if there are 14 different ands in there, all of those statements need to be true in order for the code to evaluate that complex Boolean statement to be true and then run that conditional. And now I want you to turn that around. I want you to make a prediction, look at this code right here, and think through what you think might happen when you have multiple ors. What would you do, or what would your computer do if it saw that type of statement? And just like with the ands, I hope when you saw this statement right here that you had a gut instinct because you already know how ors work. And so no matter how many ors you have, there could be, again, 14 different words of or in there. And as long as one of those simple conditionals is true, the entire statement will evaluate to be true. So ands and ors work just as expected. If it's all ands, everything has to be true. If it's all ors, only one of them has to be true in order for this statement to evaluate to be true as a whole. Now where these start to get a little bit tricky is when we mix ands and ors together. So ands and ors work differently. So what I'd like you to do is just take an educated guess. Think in your brain, what do you think you do when you have an or and an and in the same statement? So since ands and ors work differently, we have to go back to our math skills, which go back to the order of operations. And there's actually an order preference when it comes to ands and ors. So if you have ands and ors mixed together in the same statement, what you're going to do is you're going to evaluate all of the ands first. And just like multiplication, division, you're going to evaluate your ands from left to right. And then what you're going to do is after you evaluated all of the ands, you're going to evaluate the ors second, again from left to right. So in this statement down here, what you would do is you would actually evaluate this piece here. You would evaluate the and first and decide, okay, is this true or false? And then after that, you would tie it together, this or this. So that's how you would evaluate your ands and your ors. You do all of your ands first from left to right, all of your ors second from left to right, and then from there you would evaluate your statement. So it's at this point in the lesson where kids actually start to question, does the order really matter? Because sometimes you can move from left to right and you actually get the same answer as if you did the ands first. But I want to show you how it does matter and how there are times where if you're not careful, you could actually produce the wrong value. So all I'm going to do here is I'm going to leave the ors and the ands in place for right now. And I'm just going to evaluate, okay, if x is 10, 10 is greater than 8, that's true. Y is 2, so 2 is less than 3, that's true. And then here, this is 10 times 2, which is 20. And 20 is greater than 30, that's false. So that's really the situation we have here. And we're going to evaluate all of those little simple Boolean statements first. Now I want to show you how order matters. We really do have to do them, the ands before the ors. Because here, if we're to do this one, true or true. If we go left to right, here we get true. We end up with true, and then we bring the and false down. We evaluate this one here, and we get a false solution. However, if we do the and first, so true and false, that becomes false. We bring the or down, true or false, well, that becomes true. So notice here how the order does matter. You do have to do your ands before your ors, or there is a good chance that you will get the incorrect conclusion for your complex Boolean statement. So in your notes, there are 8 examples that I need you to evaluate, and I need you to decide whether the statement is true, false, or invalid. So pause the video, work through the mathematics behind it, determine is it true, false, or invalid, and then on the next slide, we'll actually talk through those answers and you can double check your work and see how you did. Okay, so hopefully you went slowly through those and you paid close attention to, am I evaluating an and or an or statement? So noticing those there. Couple of other things to point out to you. So these first 4 were just traditional ors and ands for you to evaluate. Number 5 is actually an invalid statement. That is not something that is valid in Python. You would have to split that into an and to check and see if that was true. So noticing that this is not valid. Now from here, remembering that in statement 6, the and has to come first before the or. In statement 7, due to those parentheses still come first, so we're actually going to evaluate the or first. And then in number 8, because there's no parentheses, we always evaluate our ands first, so you do ands from left to right, and then ors from left to right. All right, and our last concept that we're going to look at is something called nested conditionals. And what a nested conditional is, it's an entire conditional, so an if else, or an if elif else block that is inside of another conditional. So they're nested. That's a computer science word for it. It's inside of there. It's indented more. Computer programming is filled with nested conditionals. It's how you make decisions within decisions. So you want this true, well then you're checking is this or this true in this particular case. So it's how you get the questions within the questions within the questions. That's how you can actually write a more detailed decision-making program. So on the screen is an example of a nested conditional. What you're going to see here is you have an entire conditional here. You have an if block entirely underneath an if. And here you have an if-else block underneath an else. So notice that the conditionals are nested fully inside of another conditional. So it's nested fully inside of there, and it's really important to be aware of these because we need to be careful as we trace code. This code will only run if this statement is true. This code will only run if this statement is false. The other thing to note here are the indentations that are taking place. So notice that these are indented again to communicate, okay, this was inside of here, but then this is inside of this, which is inside of this. So notice those indentations really communicate which conditionals are inside so that you can clearly read that code. Now this example here is an example of a badly nested conditional. Notice that my intention was to link these together. I have an if and I have an else. But the problem here is that wherever this if-else gets nested, it has to be under just one of these. It has to be under the if or under the else. It can't be split. So it's only under one segment of the conditional that nested conditional can go. So be on the lookout for these. This is invalid code and you will get an error because your computer will be confused why this else is all alone by itself. And lastly, I just want to model through for you what a tracing example would look like with a nested conditional. So you'll notice here I have my example values. So x starts at 10, y starts at 3, and z starts at 30. So I'm going to go into my program, and I have z is being divided by 2, so that's 30. So this is saying 10 is less than 30 divided by 2, so that's 15. This is true, which then tells me, okay, I'm going to go in and run this code and skip this code. Then from here it's saying if z, so 30, is less than 3 times 12, which is 36. Again, that's a true statement, so we're going to skip this and run this code right here. So z is being reset to y times x, which is 10 times 3, which silly, but we're rewriting it as 30. So then from here, our output is we output x, y, and z at the bottom. So we output 10, we output y, which is 3, and we output z, which is 30. So that's our first tracing example. Notice how some of the code ran and some of the code did not, depending on the results of those nested conditionals. So now what we're going to do is we're going to go through this a second time, and we're going to have different values. So those are erased. We're going to do a different color. And here we have x is 12, y is 3, and z is 24. So we have 12, 3, sorry, that got bad handwriting there. So 12, 3, and 24. So we're going to go up. Okay, z is divided by 2, so that's 12 is greater than 12. Well, that's false. And because this is false, everything underneath here, underneath that if, is skipped. And we come down to our else, and we're going to run this code. And so then our next check is, okay, z, which is 24, is greater than y, which is 3, times 10, which is 30. Well, that is false. And because that's false, and this is a single if conditional, this doesn't run either, and we pop down here. And we print out x, which is 12, y, which is 3, and z, which is 24. So just being very careful as you go through those nested conditionals, noting which code will run and which code will not.